So, hello everyone, and welcome to this weekly session that we conduct, Ask AuxEn Anything. And as you know, that this is an online platform for civil structural engineers to interact with us and ask their doubts or queries that they may have related to steel or RCC design concepts or any project that they are doing or construction or site related queries. So, this is the 68th such episode that we are conducting. And let us begin by taking the queries that have been asked for this week. So we'll start by taking the queries from the Google form, and then we will take the queries from the live audience and email. So let us begin by taking the queries for this week. So I hope my voice is audible to all of you and you are able to see the screen as well. So the first question for this week is has been asked by engineer Vinay RB. He is from Karnataka and he is a working professional. So he's saying, how to overcome failure of beams which come under shear and torsion in ETABS. Even after providing sufficient depth, failure remains same. Please show an example to resolve it. So see, related to shear and torsion, sometimes what you need to see is that what is the reason for which you are getting torsion. If it is an equilibrium torsion, that means that torsion in the beam is there to maintain equilibrium of some other element, then you cannot do away with that torsion. But if that torsion is related to compatibility, then you can think of releasing the torsion. And by releasing the torsion, I mean that instead of torsion being generated in these beams, you can, because of the compatibility, you can transfer it to other elements like connected beams and connected slabs. So this is the first sort of process you can follow. Secondly, let's say if there is torsion in your beam and if there is shear in your beam, then to control torsion, increasing the width often is a good idea. Increasing the beam width instead of beam depth. Okay, so increasing the beam width is a good idea to control the torsion. What happens is, because of your torsion and shear together, the combined interaction, due to the combined interaction, the tau v that you get becomes greater than tau c max. So in such a situation, there is no other way but to increase the sizes or change the sizes. Now if you are increasing the size, a better approach is to increase the width instead of increasing the depth. So first of all, see if that torsion can be sort of released. If it is part of a compatibility torsion, you do that. Then whatever torsion, let's say if you are not able to release the torsion or still you are getting some torsion for which you need to do the design, then increasing the beam width instead of beam depth can be a good idea. So try these approach and then see what happens. Then he's asking how to check one-way shear in isolated and combined irregular footing of safe model. The concept remains the same. Whatever is the shape of your footing, and even if it is combined, you need to check at d distance away. So if this is column face, you check at d distance away for one-way shear. Okay, and for punching, your software is able to do that check on its own. So you can rely on the software for your punching check, two-way shear check, and for one-way shear check, as I told you, whatever may be the shape of your footing, however may be the column placement, you check at d distance away from the face of column. Now, when you go to d distance away, how much width to take, that remains a question which you need to sort of judge on your own. Because sometimes, let's say, if you take a distance away section over here, the width over here is this much. But if you were to take that d distance section from here, then you are getting a smaller width, isn't it? So how much width to take, that you need to judge on your own. by looking at the behavior, that in how much width the actual shear is concentrated. So that sort of thing you need to do on your own. For that, I cannot give you any guideline because it will depend on your own judgment. So you need to come up with that judgment on your own. But check at d distance in the normal manner in which we do. The effective width that you need to take, that judgment you have to uh, come up with your own. Okay. FEM and strip based approach. Yeah, so you can use FEM based approach or strip based approach. In irregular footings, it is better to use the FEM approach because you are not really sure about the width that you need to have. If you are making a strip, then you can make a strip as per the width that you have decided that this is the effective width over which you are getting higher shear stress concentration. So accordingly, you can make that strip width. Okay. And how about raft which combines 6 or 7 columns? Yeah, so the same thing as I told you. Theoretically, I know at d distance, but practically in safe, I want to check if the provided depth is sufficient for one-way shear or not. Another approach you can do is that you can find out the value of VC that your raft of effective depth D will provide. Okay, you put that value in the contour. There are options for minimum and maximum value of contour. If you have seen in safe, you put that minus VC to plus VC as your contour values, and then see in which region your shear is getting over and above the VC value. That will help you to make a judgment that whether this zone is sort of critical or not critical. That judgment you will then be able to make. Okay. All right. Any specific criteria that semi-rigid diaphragm to be assigned for seismic case or rigid is okay for conventional case? See, as per your code, if your slab is 150 mm thick or more, I think 100 mm thick RCC slab or more. Okay. If the overall aspect ratio is less than 3, and if there are no large openings, that opening definition is also given in the code. You can go through IS 1893. If all these conditions are being met, then you can safely assume your slab to act as a rigid diaphragm. Okay. If these conditions are being met, then you can safely assume that your slab is acting as a rigid diaphragm. Otherwise, you need to take it as semi-rigid and then check its flexibility and then decide whether it's a flexible diaphragm or a rigid diaphragm. But if these conditions are being met, straight away you can conclude that this is acting as a rigid diaphragm. Okay. All right. So these were the queries asked by engineer Vinay. Then we have next question is from engineer Pratham. He is from Kolkata and he is a working professional. So he is asking, if there is a slab on beam edge, the beam must be released as bending moment is 0 on discontinuous edges. So in ETABS, we manually select the beam and torsional modifier as this much. So should we do it in Stat Pro also? And if yes, how to do it? The question is, are you modeling plate elements in Stat? That is the question. Are you modeling plate elements in Stat? If you are not modeling plate elements in Stat, and if you have only applied floor area loads, then I think you won't get torsion. I'm not sure whether the torsion effect will still be there. I think it will still be there. So yeah, you can in STAD also you may assign the modifiers. Uh, you may assign the modifiers in STAD also. There is an option for section property modifiers or something like that under the specification tab. So you go to the specification tab in STAD, and there are options to put modifiers to different inertias and different areas and different uh, for different actions, so to say. So yeah, you can do the same thing of applying modifiers in STAD as well. Okay. Okay. Then the next question is from uh, Engineer Mayank Agrawal. He is from Hyderabad and he is also a working professional. So he is asking, currently in office I have work on ETABS and RCDC, but for manual design, how to consider continuity, boundary condition at sunk slab, and how to calculate moment and moment of sunk slab. So see, generally in sunk slabs, we assume that there is a edge discontinuity. For example, these are your column frame, suppose, and then there were some beams over here. Let's say these were your beams. So then you, and let's say this was your sunk slab. So then you assign edge releases to this slab. You assign edge releases to this slab area, and then if you want to do it manually, you can just do it as slab with four edges discontinuous. Okay, you do it as slab with four edges discontinuous, and accordingly find out the moment coefficients. Moment coefficients are given in IS 456 for slab with all four edges discontinuous. So you find moments for the slab and accordingly give the reinforcement. Okay, so that is the way to deal with sunk slabs if you have. Then engineer Deepak Pagar is asking, he's from Pune, he's a working professional. He's asking, can you explain in brief about concrete corbel design? Now, what is your question related to this? What is your specific question related to this? Corbels are nothing but brackets that you, let's say, take out from columns. So it's a bracket thing. So whatever is your load, you find out the load into this distance. You will find the moment at this cross section. Similarly, you find the shear, and at this cross section, you have the shear, you have the moment. Accordingly, you can design this cross section, find out the reinforcement, and because it's a cantilever, you need to basically the top reinforcement becomes important for you, so that you need to provide. So it is to be designed as a general bracket, this corbel, and of course for shear you will have to provide your stirrups like this. So if you have any specific question related to corbel, you may ask. Otherwise, the procedure remains the same as we have for normal cantilevers. In some situations, we may also like to use the strut and tie model for corbels, for deep, very deep corbels. But otherwise, this normal bracket approach to corbel design, small cantilever approach to corbel design is also sufficient or good enough. Okay, the next question is from engineer Shrishel. He is from Bengaluru and he is a working professional. He is asking, recently I was involved in design of STP, which we have done few experiments, and he has sort of provided the results over here. Normal model where base of wall and column are fixed, model with base slab. So I think what he's saying is that in one case, let's say I'm showing you the cross section only. So this was his column, sorry, walls in cross section, and he had just fixed it in your his ETABS model or safe model, sorry, ETABS or STAD, whatever or wherever he was preparing this. I'm showing you the cross sectional view, let's say. And in another case, he had modeled the base slab as well. Okay, so there is no fixity as such provided, and so this is, let's say, case 1 and this is case 2. Now what is this question? It is observed that there is a difference in wall behavior, deflection in walls more than walls with base slab. In reality, as we will also not have 100% fixing at base, we proceeded with second option. But is it really required? There are few STPs still working which are designed. See, if you are doing it as per one, what you will get is that you will get quite substantially high moments at the base, okay? Because all the triangular force that you will get, I mean, all the effect of entire lateral force will be reflected in the bending moment at the base that you get. But over here, what is happening? That the moment gets distributed between the wall and the slab. So there is a moment distribution that occurs. Okay. And because this is also resting on a spring-like thing, this is resting on a spring-like thing. Here, what we are considering zero rotation, zero translation, because you had provided fixed supports over here, and here you are allowing the system to rotate at this rigid junction. So because of that, what will happen, that the moments at the base over here will be distributed amongst the wall moment and the slab moment. You understand this point? So in the model 2, there will be lower moments that you will get at the wall base as compared to the model 1. Okay. So ideal situation is doing it as per model 2, but sometimes because you don't have the uh, see, these days the softwares are also good, but when your softwares were not good, then you did not have the capability to do the analysis as per 2, as per condition 2. So you used to do it as per condition 1 instead. Okay. So condition 2 will give you smaller moment values at the wall base, and condition 1 or model 1 will give you larger values at the wall base. So condition 1 is sort of a simplistic and conservative approach, but it is easier to do analytically, and therefore many people follow the case 1, but the realistic approach is case 2. Okay. All right. And because of the moment values changing at the base, there will be some moment changes that you will face uh, in the mid height of the wall as well. All right. Yeah. The next question is from engineer Yash Bhope. He is from Bhusawar and he is a working professional. His question is, please suggest me an arrangement for base plate and anchor bolts. I think he has put this query over here also. Having normal force equal to 190 minus 190 kilonewton. I don't know whether that minus sign is representing tension or compression. That you need to verify first. Whether this minus n value of minus 190, does it represent tension or compression in the column? That you need to tell me. Moment about one of the axis is 929. Column size is SHS 400 416. Pedestal size is 850 cross 1050. So because what I can see is that you are getting moments only about one of the axis, and about the other axis you are not getting substantial moments. So let's say, and your pedestal size you're saying is a rectangular size of 850 cross 1050, and column is square 400 400, and let's say the column has to resist moments about one of the axis. Let's say this is my y axis. So about this axis the column has to resist moments. So you can, my opinion will be that in box columns it is always better to provide your gusset. So this will be one of the gussets. This will be gusset, and then you provide your stiffeners like this. So in box column, to get a rigid arrangement, it's always a good practice, or always a good way to have gussets and stiffeners provided. This can be another gusset plate, and then you can have stiffener, and then you provide bolts over here. So these become your bolts. So this will add adequate rigidity to your system, and it can take moments about both the axis. Now if you are having moments about only one axis, then these bolts will, let's say moment is only about this axis yy, then these bolts will play a good part in resisting those movements. So this type of an arrangement for box column is a good arrangement to have. 190 kilonewton is tension. Yeah, okay. This type of an arrangement is a good arrangement to ensure rigidity between the box column and base plate. Uh, to ensure rigidity between box column and base plate, this arrangement is a good arrangement. Clear? Good. So these were the queries that were asked for this week. Now let me check if there are any queries on the email. Just a minute, I'll be back. Yeah, let me check email if for any queries. So on email, there is this query, Mike, from engineer Sayyed Zayed Heather. His question is, my question is for this, and he has provided an image also. Let me show the image. This is the image he has shared, Mr. Sayyed Zayed Heather. My My question for this column base plate pinned connection, which I have marked in the image, for these for this pinned connection, how to get reactions. So he is asking for this. So first of all, I hope you have assigned a pin. I mean, you have assigned the necessary end conditions over here. So you need to assign the relevant end conditions over here in the STAD model. I hope you have done that. And now, how to get reactions from the STAD. So end conditions you can give for the member end. At the member end, you can give the necessary end condition, or at the node also you can give necessary end condition. And once you do that, now if there is no support as such assigned, you will not get any reactions per se. But then you can look at the member forces. You can look at the member end forces, and from the member end forces, you could get the reactions that you want for the connection design. So you may not get it as the reactions because there is no support assignment that has been made over here. But from the member end forces, you can go for the connection design. Okay. All right. So this was his question. There were no other queries on the email. So now let us look at the live audience and let us look at their queries. So first query from the live audience, Engineer Arvaz is asking, what is the shear enhancement factor as per ACI 31825? Shear enhancement, where was the shear enhancement factor? Shear enhancement factor as per. There's so many factors in ACI that I also need to see. Can you give me the codal provision or clause number where you have come across the shear enhancement? Because if you give me the codal provision, it will be easy for me. Okay. Okay. In the meantime, let's take query from Engineer Ishan Desai. He's saying he has shared his image on WhatsApp. How can I model this system on eTabs? This is the image he has shared. And what is the question? How can I model this system on eTabs since two slabs are connected by the ISMB when the machine is at rest? In test condition, the air vibrator will inflate. Okay, so this blue thing is the vibrator. It will inflate and carry all the loads of the seismic block. And then what he has written, issue is that I'm not able to do. His issue is that I'm not able to model two slabs connected by ISMB by line element at different levels. So I think one is this his slab and one is this seismic block that he's talking about. This slab is being supported by these columns, and then there is this ISMB line element, ISMB members. On these ISMB members, the seismic block is resting. On the seismic block, this machine is there. Then he is saying that in test condition, so in the condition at rest, these blue things are deflated. There's no air in them. So the load transfer is happening through seismic block, from seismic block to these ISMBs on the slab. And then in the test condition, these will expand. These blue things will expand, and then the seismic block will be lifted up, and then the load will transfer through these inflated items to slab. So he's asking, how can I model these two slabs separately? So I think instead of having them in one model, you just make a model for this slab and the column below. I don't think there is any need for you to make a combined model of slab and seismic block, because the load transfer is anyway taking place from seismic block to slab. So you model it, you only model the slab and column. You model one as the one model, you have it as the rest condition. So in the model where you have made a rest condition, you just assign the loads through these points, ISMB locations. So this becomes your model 1. And in the next condition, you make the test condition. So in test condition, you assign the loads through these inflated blocks on the slab. So you design your slab and columns for that. For the design of seismic block, again, you can make a separate model where under the test condition, it is the machine load over here. And under test conditions, it is resting on these ISMBs, which provide supports. and you make another model for your seismic block and machine, where in inflated conditions the reactions are being provided by the inflated blocks. So you make separate models. No need to combine everything in one model. I don't think that will be of any use for you. So have separate models made, because anyway these are unconnected. Unconnected means they are not getting directly, no stiffness transfer is taking place between your seismic block and the slab. So it is better to do it this way. Okay. ISMB will bend considering both slabs in action together. Why will it bend? Isn't it resting throughout the slab? I do not have the plan view, but what I'm assuming is that this slab is the entire area element. I mean, this must have some plan dimensions, this slab, and your ISMB is being provided throughout the other direction of slab. This is what I'm assuming. And see, there is no stiffness transfer between the seismic block and the slab. So it is only the load transfer that is taking place, because your seismic block has been just kept on the top of the ISMBs or the inflated blocks. So no need to model it together. Okay. Then Mr. Ishan Desai is asking another question: for retaining wall, if we are providing shear key, why should all the bars of stem developed into the shear key, or should it develop into the footing? See, as long as your bars have been provided effective development length, that is good enough. Even if you do not take it to shear key, it's okay. That means, let's say he has this condition and his shear key is like this. So he's asking, should I develop all the bars from the stem to shear key? Answer is that beyond this phase, you need to have development length. Now, if you are getting the development length by developing the bars inside the shear key, or if you are able to manage the development length by bending the bars like this, whatever you are able to do, it's fine, as long as you get the development length beyond the stem face. Okay. All right. Then the next question is from engineer Chetan. Why for transfer beam slab design, additional 2.5 factor is considered? Why not 1.5? I don't know. I don't know. I'm not sure where these factors are given, so I'm unable to comment. Do you have any written reference where this 2.5 is given, or it's just a practice that you have seen people following? In either cases, I do not know. Yes. Maybe 2.5 for additional safety, because this type of, the transfer beam or transfer slab is a critical element for us. So maybe we are over designing it just to be, because of its criticality. That might be the reason, but I don't know where this reference is given about 2.5 and 1.5. I'm not aware. Okay, then. So anything else? So we have taken all the queries from the live audience. We have taken all the queries from the Google form and the email also. So yeah, so I don't think there are any further queries now. Yes, anyone having any other query? Okay, so as you know that we meet every week once and we take up your questions. The link for putting your queries remains the same. So this is the link to put your queries. You can put your queries throughout the week in this Google form, and once every week when we meet, we will take up your questions in this live session. Okay, so this is the link for the Google form. Mr. Srishail is asking, please explain the wall axial stress limit 0 point, it's not 0.04, it is 0.4 FCK, and it is not for the walls but for the columns. 0.4 FCK is the stress limit for your axial members subjected to earthquake loads. So under the effect of load combinations involving earthquake, your axial stressors shall remain less than 0.4 FCK if you want to design them as columns. If the axial stress under the effects of lateral loads they go beyond zero point 0.4 FCK, then you have to treat them as walls, shear walls or RCC structural walls, and accordingly do their design. So this is the requirement given in the IS 13920 for columns which are subjected to axial loads under the effect of lateral load combinations. And why is this requirement given? Because for columns, if they are subjected to heavy axial stresses, they may lose their confinement, and if they lose their confinements, it may be problematic in the axial load carrying capacity, and any sort of axial failures in the column may lead to a global collapse. So to avoid that, this sort of a provision is given. Okay. Okay. So this is the link for the Google form, and you can connect with us if you want to connect with us on WhatsApp. This is the link. So to send us a direct message, you can click on this link. Yeah, this is that link for connecting with us on WhatsApp. So this was today's episode, and we took all the queries that you had asked. So you keep putting your queries. Next time when we meet, we will take up the queries that will be asked during the coming week. Till then, have a good time and have a good week ahead. Bye bye, everyone. Thank you for joining.